So let me talk a little bit about the kind of data that exists, and then a little bit about deeper what we do, right? So it'll be the next set of slides I'll go through fairly rapidly to give you a flavor more than anything else. Is first thing is, what does data itself say? What does some of the models that you build say about the data, and then how do you build systemic intelligence, right? So first thing is, right, just the fact that you have 75 million registered users who are browsing, buying, blah, 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 you have a very clear idea of a lot of things about, at least I wouldn't say about India, because that's a very wide this thing, because if you look at it, all of internet penetration, all of that is the top 200 to 50 million people in India. At least for that population, you have a fairly good idea of what they do, what they sort of what the behaviors are. So this gives you a reading preferences in different parts of India, right? This is kind of a funny thing of where do you buy a lot of shoes and where do people wear high heels, right? It's very interesting. The kind of things you can learn from our data is very, very interesting about India, right? Purchase patterns. So where do they buy a lot and where do they buy expensive stuff, right? This is Bangalore, right? And this is Mumbai, and things like that, right? So just looking at data at this scale, right, will tell you a lot about commerce in India. And again, like I said, commerce in at least that population of India. And one of the goals of Flipkart is to sort of percolate commerce across the different cross sections of India, albeit till date, if you look at the entire e-commerce, it's on the top 100, 200 million Indians, right? So now examples of data-assisted human decisions, right? This is where the organization, means the analytics, data sciences organization comes in, where the focus of the organization goes from strategy and execution, which is the core sort of, the analytics organization holds the key to defining what the company should be working on from a metrics perspective, right? What are the things we should measure and what are the things every CXO in the company should be measured on, right? That's the strategy and execution. I'll go into, it's done through fairly deep science, right? It's done through a lot of statistics, modeling and so on. I'll go through a little bit of that. And then there are the more conventional areas, marketing, customer analytics. Then the other thing is growth hacking, identifying opportunities for growth. Seller marketplace analytics. We run a huge, means we have around 100,000 sellers in the platform, understanding who are the good sellers, promoting them, who are the fraudulent sellers, making sure they don't appear in our platform again, and so on and so forth. Supply chain, logistics, network optimization, driving service, right? Demand modeling, right? Trust and safety, right? Demand modeling, understanding, planning, forecasting, trust and safety. Channel analytics, understanding how consumers behave on different channels, right? Customer service and experience. What really drives customer experience? What is painful for the customers? What's delight? Defining that in a very, very quantitative manner, right? Business category analytics, understanding what? And people, right? So I'll talk about the first. This, for me, if I look at it, if I look at my biggest sort of most impactful charter of the analytics organization, it's this, right? Basically defining what the company should be working on, right? So you have a strategy, right, which is defined at the end, starting of every 2 quarters, let's say, right? And based on the strategy, you identify what are the key areas of focus. And based on those areas of focus, you understand what are the key metrics you want to drive. It could be traffic, it could be repeat customers, it could be things like that, right? And then comes the difficult part, right? Then how do you break into what are the real, true input levers of each one of these? So the point essentially is, while everybody knows experience is important, very, very few companies in the world, in the retail world, right, in general, know what really drives experience and by how much for that population. So that is essentially what it does, right? So for example, and this is what we call the Kpi tree, right? This is built through statistical models, right? So basically what we do is, hey, here are some of our key L0 or the key top line metric. We have to drive traffic, we have to drive conversion, repeat customers, grow customer acquisition, consumer experience, profitability. Let us say this is our business, right? Then to be able to, so we build deep statistical models to understand what are specifically the input drivers for each of these and what are important, what are not important. And basically, I should be able to forecast my entire business, simulate my entire business through models. Basically, if I want to drive traffic, these are the levers I have. I move these up, move these down. This is what will happen to traffic. If I want to drive conversion, I will talk a little bit about conversion. Oh, here are the drivers, right? So, building deep scientific models on basically everything. So, the key point is this, right? For example, one may think traffic for an internet company is driven by search engine marketing, SEO, so on and so forth. But one of the biggest drivers of traffic is your diversity of selection in certain categories, right? How do you derive that? So the point is, you don't want to put the onus of traffic on the chief marketing officer's head, because some of the biggest levers are not even controlled by the chief marketing officer, right? So to have a very nuanced quantitative view of, if traffic goes down, should I look at the person, the chief business officer? Should I look at the chief marketing officer? Or should I look at actually the head of service? I don't know. You should be able to build models, and that's the purpose of this, right? Typically, companies don't know. They just make one person. See, how does governance happen, right? You make somebody own a metric, and then if the metric goes down, you beat up on that person. If the metric goes up, you sort of praise that person. But the drivers of the metric may not be sort of owned by that person, because that's the reason it's important to understand what the key input drivers of these metrics are. And that's a very complex problem. That's a very deep statistical problem, because all of these, there's a lot of correlation, collinearity, so on and so forth. You have to be able to tease out all that and actually say, if I have to drive traffic, what is the impact of more selection? What is the impact of better search engine marketing? What is the impact of SEO? What is the impact of better service on actually driving traffic, right? And these are owned by different people. So everything has to actually break down into a tree, and goals are set at that level. While this is probably sort of looks like governance, it's actually a lot of science goes into building this. Right? For example, right, this is a very classic example. So what does service, what are the key drivers of customer experience? One thing is, customers want to feel that they got a good deal. That's probably the most important, right? Then they want to get good quality product. They want to make sure that it's ordered on time. They want to make sure the pricing is good. They want to make sure if they have a problem, it gets resolved quickly. But if you look at it, customer service is owned by a whole bunch of organizations. The first bar is owned by somebody who's running the business category. Second bar is again owned by the seller platform, because that's what makes sure the quality of products is good. For the order to delivery time is owned by logistics. Time to resolve contacts is owned by customer service, so on and so forth, right? So it's a very, very everything, right? So to be able to say what is important and how important is something, and to be able to say when something is important, how do you sort of create accountability, and who is accountable is a science. It has to be run like a science if you want to drive efficiency. Right? Then the classic, this is probably the most common application of analytics, customer segmentation. This is the methodologies. I won't go too deep into that. But segmentation based on behavior, based on how much people spend, the diversity of purchases, what is their potential, what is their seriousness, and how often do they come to Flipkart, and based on that, we build our segmentation framework. And this is the segmentation framework which is used first to understand how different people behave differently. For example, here you see at different areas, there are certain segments which, if you look at certain segments, they return a lot. Certain segments come only during sale period. Certain segments, so every segment has its own sort of characteristics, and they have their own, again, category preferences. This is indexed values for segments on what they prefer. So different segments behave differently on how they purchase, but also what they purchase, right? And finally, they also are different from a profitability perspective. Some people just buy and keep returning. Some people buy keep buying, don't return. They have different profitability implications. Some people are really happy, some people are not nearly happy. So each one of these, once you have this becomes a framework of personalization, recommendation, CRM, so on and so forth, right? These are some of the key applications of, this is one area, right? Second area obviously is, we talked about, is conversion, right? Conversion in e-commerce again is not people coming to website and buying. It can be broken into very, very key pieces which are owned again by different things, right? One is discovery, right? Did you find what you wanted? Then when you went to a product page view, then you go to a product page view. Once you went to a project page view, did you actually convert? They are governed by very different things. Discovery is governed by how good your search engine is, how good your personalization is, so on and so forth, right? Whereas once you get to a product page view, you're seeing actually a product. From that point, it may depend on other things a little bit more, like pricing and so on and so forth, right? So identifying actionable levers for conversion at a granular level. Most important is the third bullet, right? Each category has its own sort of value proposition to the consumers. So what drives conversion is that value proposition, right? For example, if you look at women's clothing, the topmost driver of it is swipes on the app, which means you want to have a lot of comparable selection, colors, designs, so on and so forth. So basically you're able to actually do a lot of browsing and shopping much like you would do in a brick and mortar store, right? Whereas if you look at large appliances like TV and so on and so forth, it is certain brands, right? So understanding what brands drive conversion is probably the most important if you look at it, right? So obviously what you see is some attributes are similar, but some are very different. If you take electronics, it's actually a lot of people come to Flipkart in electronics and mobiles for discounts. So that comes out here. Maybe you want to change that behavior, but currently that's what it is today. That's what is driving conversion, is a lot of price. So in women's clothing, it's driving a lot of selection, the ability to browse through and look at a variety is what drives conversion. In large appliances, it's more the brands, having the right brands that consumer want, and in electronics, it's much more related to sort of getting a good deal and so on and so forth, right? So now going into a little bit deeper, right? So these are all things that help drive decision making in a human manner, right? But the point is, the way you want to think about it is, it's not like certain problems are for human decision, certain problems are for machine intelligence, right? Like you heard in the last talk, the goal is to keep driving machine intelligence and keep driving more and more human decision making into the machine intelligence, so that most, other than the most strategic decisions, most of the tactical operational decisions get made by the machine, right? So if you look at it in today's world, there may be a future world where literally all decisions could be made by a machine, but today machines are very good at making quick operational decisions, while humans today are good at making far-thinking strategic decisions. So right now you should try to drive as much as your operational decisions down to the machine. So here are some areas where we work on personalization, recommendation, merchandising, review mining, address classification. I'll talk a little bit about that, demand elasticity, user insights. These are all things that are on the machine, and they are actually leveraged to make decisions on the fly. For example, take a seller rating fraud, right? This is sellers sort of get rated on Flipkart, and which seller gets discovered and gets the buy now button, which is at the top, depends on their performance, their rating, their quality, so on and so forth, right? And so there is, it's ripe for somebody to try to defraud the system. For example, there may be a seller who may come in as multiple users and keep giving a poor rating to their competition and a really high rating to themselves. So how do you figure this out in scale? The way you would figure this out in scale is you start looking for clusters of, these are edges, right? These are network, means graph edges, where you're starting to see where each edge is when two users have at least 3 or more common sellers, right? So what you're seeing here is clusters being formed where a whole set of users have the same set of sellers, right? Basically, and now you dig deeper into the data, what you will find is the ratings, the timestamps in the ratings, the huge disparity, all the competition being the 5s and 1s and all the cell for one particular cell getting all 5s and so on. So you can build a machine learning algorithm around this and then actually detect real time when a fraud is happening. Another classic systemic intelligence that we built is how do you, so you have these field executives, right? So, but how do you get them to sort of deliver to the right address? You need some landmarks and so on. And here is the classic problem, right? In US, this is a very simple problem, right? Addresses are very standardized. There's a street name, there's an apartment, usually they're all spelled correctly. In India, it's very difficult, right? If you ask me my address, I live in 71 Lakeshore Homes, Hosa Road, also called Central Jail Road, near Amrita College of Engineering, and sort of 2 other landmarks, and then there is a thing, right? So, and again, then the other thing is not being standardized, a huge amount of spelling errors, so on and so forth. Some of these are very, apartment is spelled 263 different ways, Whitefield 24 different ways, Bangalore 161 different ways, and so on. This is actual data, right? So how do you solve this, right? So to solve this, what we do is, again, we use the field executives to label data for machine learning, and then we do a lot of natural language processing, pre-processing of the data through looking at historical data, but also looking at different patterns, and so on and so forth. And then we build a model that is able to classify, given sort of an address, I would say it's right next to Koramangala BDA, right? This is actually trained on this thing, sort of label data, but then there's a lot of intelligence that gets created through the pre-processing. Pre-processing is the tricky thing because of actually this, right? And then you are able to actually provide the field executive with a clear landmark near BDA, Koramangala, or near Park Plaza Hotel, or whatever landmark that person is able to understand. And another last example, and then I'll stop for questions, is, right?